All right, if you're still here, we're now going to get into how we can find the standard deviation for a frequency distribution. So it does involve the same process. We still have those 6 steps, but there is going to be a subtle extra step in the process. So we have a frequency distribution here, and I've already set up some extra columns that we're going to need to fill in order to get the standard deviation. But let's start with step number 1, which hopefully you remember is to find the mean. So if we're finding the mean in the frequency distribution, though, we need to do a little bit of other steps. So let's see if I can get my camera straight, and then we will get going. All right. So this first column, x times f, remember, when we're finding the mean of a frequency distribution, we can't just add up those values because we have to take into account how many iterations or repetitions there are in those values. So again, there's 2 1s, there's 5 3s, 7 5s, 4 7s, and 3 9s in this data set. So if we wanted to add those all up, we need to make sure we take care of all of them. And the way to do that is to multiply. So if we multiply straight across, we can take care of all those iterations. And so there's all those products. We've batched those numbers together. Now we need to add up those numbers, and that will give us the total. So again, to make sure we do it correctly, let's use our calculator. So let's add and 35 and 28 and 27. So 107. So 107 is the sum. And now, what do we want to divide that by? Now be careful. Don't say we want to divide by 5. There's more than 5 numbers in this list. So we want to make sure we count for all of them. So we have to add up the frequencies. So what do we have? 7, 7, and 7? Looks like 21. So if we divide this by 21, we get 5.095 and change. 5.09. 5, 2, 3, and so on. Again, we don't want a lot of decimal places, so let's just round it to 1. Now you might be tempted to round this to 5, but you want to have a little bit of accuracy. So again, have that one extra layer of accuracy than your data. So we need that one extra decimal point. Okay, step 1, done. Step 2, remember, is subtract. And that's what this next column wants. So we need to subtract all of those values minus the mean. So again, the value minus the mean. So 1 minus 5.1 will be negative. A negative 4.1. 3 minus that, negative 2.1. 5 minus that, negative 0.1. And now the numbers are bigger, so we do get positive answers. So 1.9 and 3.9. Okay, so there's step 2. Step 3, we don't like negatives, so we square them to get rid of them. So let's do those on the calculator. So 4.1 will give us 16.81. 2.1, 4.41. 0.1, 0.001, 1.9, I want to say it's 3.61, and 3.9, 15.21. All right. Now, normally at this point, once we've squared them, we usually add them. But why can't we just add these 5 numbers up? And hopefully you're saying, because we don't have 5 numbers in our table. Remember, there's 21 numbers in here. So these would only account for if we had 1, 1, 1, 3, 1, 5, 1, 7, and 1, 9. And we got a lot more copies than that. So we have to multiply by the frequency to take care of those other repetitions. So if we multiply by 2, That's going to give us 33.62. If we multiply by 5, looks like we get 22.05. 0.01 times 7, 0.07. 3.61 times 4 looks like 14.44. And 15.21 times 3, 45.63. So now we have all of those copies taken care of in these values here. So now we can actually do step 4, which is the sum. So we have to add those up. So let's see what we get. 3362 plus 22.05 plus 0.00, whoops. Let's try that again, Lee. 33.62 plus, no, start from scratch. Again, make sure you reset it to 0 if you mess up. Plus 22.05, 0.07, plus 14.44, plus 45.63 equals 115.81. Now, when you have these big tables like this, and you have lots of things to add up, but you're not 100% sure which ones to add, which columns do I add? Here's a little tip. Any column that has an F is one you should add up. Only those columns that have an F. These other columns, you don't need them. Don't add those up. They don't give you anything worthwhile for finding the standard deviation. So, okay, but now we have our sum. So now we can go to the next step, step 5. Step 5 is divide. Remember that rhyme. Step 5 is divide. So we have our 115.81, and we want to divide by n minus 1. Well, we got 5 numbers minus 1, so that's 4, right? That's a big no-no. We all know that. We shouldn't divide by that because we need an eraser. No, because remember, this value is n. This is the number of values in your table, not 5. Be careful. So minus 1 though, so we want to divide by 20. So let's see. I cleared it, and I shouldn't have cleared it. And let's divide it by 20. 5.7905. 5.7905. And now your last step, remember, is square root. So this time I didn't clear it. And so now if we square root it, 2.4063457777. And this one does look nice if we just round it to one place. But you remember, you can do either 2.41 or 2.4, but just follow the directions. The directions usually specify how many places to round it to. So as long as you do that, you will be safe. Now, to move on to the next question, which we're not going to do in this video, but something to think about, how can we find the standard deviation for a frequency distribution with class limits? So those grouped frequency distributions, how do we tackle those? You'll see in the next video. Stay tuned.